Okay, so we are to Unit 6, Lesson 3. And this lesson talks about medians and altitudes of triangles. Now, in this lesson, it is extremely important that you go through the vocabulary, okay? Because these terms, I'm going to use these terms, and I'm going to expect that you know what I'm talking about. So knowing what the definition of a median, centroid, altitude, ortho center, be able to have those definitions written down so you can at least reference them, okay? So I'm going to jump right to this first theorem. That's called the centroid theorem. So the centroid of a triangle is a special point inside a triangle, okay? And it's the intersection of these things called medians, okay? And what a median is a median connects a vertex of a triangle to the midpoint of the opposite side. That's what a median is. And if you draw all three medians of a triangle, you get what's called the centroid. So, for the centroid of a triangle, a special thing is that it splits this median into chunks. So this AP is 2/3, okay, of the length. PE is 1/3 of the length. So from the vertex to the centroid is 2/3 of that median. From the centroid to the side, it's 1/3 of the length. But the main thing I want you to know is a centroid connects a vertex to a midpoint of the opposite side of that vertex. So example 1 is going to get us some practice creating the centroid of a triangle. So like the other examples we've done in lessons past, we've got to graph this triangle first. So the point R, vertex R, 2, 1. Vertex S, 5, 8. And then vertex T, 8, 3. And we draw our triangle. Okay? So what we've got to do is really, to find the centroid, we need to find midpoints. So midpoints the midpoint of RS, ST, RT. Finding all those midpoints. So to find the midpoint of RS, remember, average of the x's, average of the y's. So the midpoint of RS is going to be 2 plus 5 over 2, and the y value is going to be 1 plus 8 over 2. So that midpoint is going to be 3.5, comma, 4.5. Okay, so I'm going to graph the point 3.5, 4.5. And it's going to be a little weird, but it's right here. Okay, 3.5, 4.5. So I'm just going to draw that median right now, best I can. Okay, so that's my first median. Midpoint of ST, average of the x's, average of the y's. 5 plus 8 divided by 2. 8 plus 3 divided by 2. Okay, so that midpoint is going to be 13 divided by 2, which is 6.5. 11 divided by 2, which is 5.5. So graphing that median, or that midpoint first, 6.5, 5.5. It's going to be right about here. So I'm going to connect those two. And really, we've already found our median, but I still want to do RT. So the midpoint of RT, 2 plus 8 divided by 2. 1 plus 3 divided by 2. So the midpoint of RT is the point 5, 2. That's going to be right here. So my graphing was a little off. But finding those midpoints, that's review. So that's why I kind of went through that quick. But we see where all three of those medians intersect. It's that point right there. So the centroid is the point 5, 4. Okay? So the centroid of a triangle is always going to be on the inside of the triangle. That point will never fall on the outside of the triangle. So really, you only need to find 2 medians in the coordinate plane to find a centroid, but it's nice to get all 3 because then you can really see where those points or those segments intersect. So I threw a guided practice in there to get you some practice finding the centroid. So again, same process as example 1. So great chance for you to pause the video, check your answers when you're ready. Okay, so for this is mostly a chance for you to check, but finding the midpoints of all the sides, connecting those midpoints to the opposite vertex to create a median, figuring out where those medians intersect. They should intersect at a nice point. I got the point -1, +2. So double check your work with the midpoints, but that's the main thing. Be able to find midpoints. That's how we find a centroid. Okay? So I'm going to fix this image, make this slide a little bit bigger, and we're going to talk about how to use an altitude of a triangle. So, coming back to the vocabulary, an altitude of a triangle connects a vertex to the opposite side, but it's got to be a perpendicular segment. So if I have an acute triangle, my altitude is on the inside. So acute it's inside, okay? If it's obtuse, an altitude can be on the outside. You see in the second triangle how I extended this side to create an altitude, all right? So that's an important thing, and that's going to connect our Ortho Center, okay? So Ortho Center, the lines containing those altitudes intersect at a point. That point is called the Ortho Center, okay? So this diagram here with the 3 triangles is very important to telling where the Ortho Center of a triangle winds up. Acute, it is inside, okay? The Ortho Center is inside if it's acute. A right triangle, it is on the triangle, okay? It is on the triangle. And if it's obtuse, it is outside the triangle. So those are some important distinctions to make for the Ortho Center, okay? So, moving ahead to example 3, we're going to talk about how to find that Ortho Center, okay? Again, first thing, graph our vertices of our triangle. So the first vertex, -5, -1, is vertex X. -2, +4 is vertex Y. 3, -1 is vertex Z. So I'm going to do my best to draw these sides straight as can be, okay? So, Ortho Center, we've got to do some perpendicular stuff. So I'm actually going to do slope of each line, okay? So slope of XY, YZ, XZ, okay? Slope. So the slope of XY, you've got a graph. You can count it. The slope of XY is up 1, 2, 3, 4, 5. 5, up 5 over 1, 2, 3. So the slope is 5/3. So what I care about is the perpendicular slope. And remember, opposite reciprocal. Opposite of positive is negative. Reciprocal of 5/3 is 3/5. Okay? So, I'm going to use blue. Or no, I'll use green. Green to show this. So I've got that slope of -3/5 for this side XY. So the way I find that altitude is I count from the opposite vertex, point Z, I highlighted that in green, and I go -3/5. So technically I would go up 1, 2, 3, left 1, 2, 3, 4, 5. So that is my altitude going through that point. okay? So it's counting that slope. So that was a little tricky. So I'll kind of help with that with YZ. Now with YZ, our slope, down 1, 2, 3, 4, 5. So negative 5 over 1, 2, 3, 4, 5. So really the slope of that line is, that side is negative 1. But we want the perpendicular slope, which would be, opposite would be positive. Reciprocal of 1 is 1. So the perpendicular slope is just positive 1. Okay? So I know I need a slope of 1, and I count from the opposite vertex, which means I count from vertex x for YZ. And you can count it however you want. We can just go up 1, right 1 to create our line. Up 1, right 1, up 1, right 1, up 1, right 1. And we can see already, looks like they've intersected a distinct point. But I still want to get the slope of xz. Xz is horizontal, 0 slope. So perpendicular to horizontal is vertical. So I'm going to draw a vertical line that goes through the opposite vertex, which is y. And we can pretty clearly see where that point winds up. That point where all the altitudes wind up is called the Ortho Center. Okay, Ortho Center. So it's a point, we call it a point of concurrency. So this triangle is acute. Okay, this triangle is acute. So our last example, our guided practice. There's another one. Try and use the last one as an example. If it's still not making sense, I can still help you. But it's finding that ortho center, all right? So I'll give you a chance to do this. Take your time, pause the video, check your answers with me when you are ready. Okay, so to explain this, when you graph this triangle, you should be able to tell that it's a right triangle. So if you look back at this diagram I gave you a little bit earlier, a right triangle, it's going to be on the triangle. So we know that the orthocenter is going to be on the triangle somewhere. Now for me, easiest thing for me is to recognize that KL and JK are vertical and horizontal lines, so it's easy to find perpendiculars to those. So once I find that, I know where they intersect, so I already know where that orthocenter is. It's point K right on the triangle.